Tell me when you're ready. Ready? You are? You're amazing. Welcome, everyone, to day 2 of the National Workshop on Data Science Education. We had a really nice evening last night for those of you that were there. Beautiful sunset, nice hanging out. We will potentially we don't have an event for tonight, but maybe we will pick a local place with a large outdoor area if some people want to go get food afterwards. Will people be interested in going out afterwards? Yes. Yeah, okay. I'll put a place by the end of the day. Maybe this time we'll pick a place closer to the Graduate Hotel, because yesterday was closer to the Marriott Hotel. Without further ado, today is about like program planning, program design. We're going to start with data science undergraduate studies. We're going to go to CDSS, the big project that we're working on here. Afternoon, we'll have some really exciting tech talks. We have the HCE part of our program is here. Excited to hear from them. We'll hear about Data 100. And in the afternoon, we will hear from our partners from Tuskegee and talk about the project that we're working on with them on building Data 6. So lots of great content today. And thanks for all your engagement yesterday. Keep it coming. Keep the comments and you know, the conversation coming. We hope we can keep with that conversational tone today.
All right, great to see you all. So we spent a lot of time talking about the first course, but after we built the first course, students asked us what was next. And so we've kind of been building furiously since then. I thought we'd just spend some time today talking about how things are structured at Berkeley, because that comes up so often in discussions about how this might get deployed at other institutions. Again, if you have questions along the way, just stop me and ask, and hopefully we can make this useful for you. So I'm actually going to start with some like university org structure stuff, which is a little dry, but sometimes relevant. And then we'll talk about courses and co-curricular programs, things like that. So there's a unit on this campus. Am I doing it wrong?
You're doing fine. I'm going to elevate the owl one more time.
All right, I'm trying to stay low. So I'm in the video chat, you know. We have a unit called Data Science Undergraduate Studies, which is focused on undergraduates. Manages the degree programs, the courses, and a variety of co-curricular programs, like the Data Scholars program you heard about yesterday. This is actually not part of any department here on campus. Instead, there's a governance committee that has some folks from electrical engineering, computer sciences, statistics, but also faculty who represent the domain applications of data science and the human context and ethics work that we do on this campus. And yeah, it's sort of a rotating group of faculty that govern this unit. And what does it do? It does advising for undergraduates, instructional support, career support, that kind of stuff. You know, puts on a big commencement ceremony, that kind of thing. But importantly, at the moment, it's not a department, and so it doesn't hold any academic senate faculty. Like I, for example, am still in computer science, even though I spend a fair amount of time working on data. And it's independent. This is like an interesting part of how things developed at Berkeley. Because then we tried to run this program within existing departments, but it was just too much work. And so one of the goals of forming this unit was to have it be independent from other academic departments, so that like the financial concerns and administrative concerns of running this program didn't fall on units that already had a lot to do. Yeah. And who's it run by? Well, Christina, who's here. So I think I'll give you a chance to introduce yourself and talk about anything you want. Yeah.
Thank you. Can you hear me in the back?
Yeah. The mic actually does work pretty well, I think.
Who runs this? We all run it. I'm Christina Teller. I've been in my role as executive director for almost a year. So I started in July last year, shortly after last year's national conference or national workshop, sorry, that was online. And so I've been hearing about this event for almost a year and been really excited to be part of it. I've been on campus for about 8 years, and I was drawn to CDSS overall, which you'll hear more about, and data science undergraduate studies specifically because of the interdisciplinary collaboration and really the focus on equity and access for students. My dissertation research focused on community college, first-gen community college students who transferred from a California community college to UC Berkeley using a critical race theory framework and Yasso's community cultural wealth. I don't know if anybody's familiar with that, but if you're looking for a way to understand the experience of traditionally underrepresented students from a strength-based perspective, Yasso's community cultural wealth is a really wonderful framework. And I just feel super lucky to be part of this team and to be able to be in an academic space that can really sincerely focus on issues of equity and access. And because we are kind of not a department, we're not a totally structured entity, we do have more freedom and we do get to make more decisions so we can do things more intentionally. And so I'm just thrilled to have everybody here and looking forward to learning from everybody today. And thank you. Enjoy.
Thanks, Christina. Yeah, so Christina has been very busy with internal stuff because there's a lot going on here, but I know she's thrilled about the idea of outreach and support of the global community working on data science education. So I want you to know that she's out there ready to help you out or collaborate if you want. There's kind of two views of data science. There's the courses that we built in the undergraduate program, but then there's the intellectual movement that's happening across the campus where lots of different collaborations are happening between different departments and different fields are changing in order to use computing in new ways. And so for that, there's a much higher level entity called Computing, Data Science, and Society here on campus, which does hold departments and administrative units. And data science undergraduate studies is like one piece of this, but it includes this statistics department, the whole School of Information, the Berkeley Institute for Data Science, the Center for Computational Biology, and the Electrical Engineering and Computer Sciences Department, which is in collaboration with the College of Engineering, and a new program called Computational Precision Health, which is a joint program with the UC San Francisco Medical School. So there's probably more of this to come. You know, this is an extremely fertile area, bringing together different disciplines for interdisciplinary work. But I'm not going to tell you about that because the Associate Provost, Jennifer Chayes, who's wonderful, is up next, and she's going to tell you all about what's going on there. So just to be aware that there's a very large structural shift of how this university is organized happening. And within that exciting shift, there's an undergraduate program, which I spend most of my time on. And that's what I'm here to tell you about for the next few minutes. Cool. Okay, so let me tell you about our courses. Oh, go ahead.
Yes, good morning.
Good morning.
Thank you for sharing that. This kind of reminds me of a matrix organization structure whereby you combine the expertise of different faculty across the campus, and the particular project or the particular program is operated with a particular objective or purpose. The question is, and I love this approach that Berkeley has, for faculty that are in different academic units, is there an issue in terms of accounting for their time and effort and workload by contributing to the data science program?
Yeah, that is a great question. We have managed to grow the program despite those challenges. So let me tell you a little bit about how it works here. EECS department, this one, and the statistics department made a commitment early on that they would cover the core data science courses with faculty time, which means that if faculty from those departments teach those courses, they get credit just as if they were teaching a statistics course. And that was important. Otherwise, I don't think we would be able to staff these courses effectively. But those are not the only departments that have contributed faculty time. Yeah, and other departments have just made the decision that they're interested in supporting this enterprise, and so they've allowed their faculty to teach these courses, oftentimes through cross-listing the course. So for example, the Human Context and Ethics course, the largest one, it's called Human Context and Ethics of Data, is cross-listed with history, and oftentimes a history professor will teach it. And since they're actually teaching a history course, which is also a data course, they get credit for it, I think is how it works. So it's nice to have kind of a core, but in order to support the program. But once you have that, then I think like filling it out with other courses hasn't been too much of a problem. So let me tell you about the kind of the space of what we have here. So let's see.
Just go down with the arrow key.
What do you want me to do?
Just use the arrow down.
I'm trying to
But
see
everybody
what this thing is.
It's touching the screen, it turns out.
You got to touch the screen. Oh, that's
Yeah.
crazy.
But I was just been doing down arrow.
Okay. No, I was just trying to move my head so you can
You
see
can also do
my
it by
color coding.
actually touching it.
Cool.
Us Mac people were like, what?
Oh, that's magic. Okay. So there are courses that are listed as data courses, and then there are courses that I think are effectively data science courses. They just happen to be listed somewhere else. I included them in this chart just so you can see what a program looks like from our perspective. We were trying to build toward a major and a minor. It's not the case that all the courses that students take to fulfill a major and a minor are data science courses. Instead, they take courses from across campus, but you do need some kind of core. So we have Data 8, which we talked about. We have an array of lower division courses, and economic models, which builds upon Data 8. And Eric teaches it. So if you want to know about that, ask him. There's a kind of mathematical statistics course. That's a lower division course. Sort of builds upon Data 8 and covers a lot of the mathematical topics that are natural questions to ask after you look at the Data 8 material. This is a programming course. So someone asked yesterday, when do students learn SQL? And when do they learn the rest of Python? Well, we have a course specifically to be paired with Data 8 or taken just after it that covers the basics of programming. The math departments decided that they want to be participating in this, and so they've just created a numerical linear algebra for data science course, which is a variant of their linear algebra course that is really tailored toward the curriculum that students are taking here. And then we have a variety of small seminars. We call them connector courses, which are about domain-specific applications of data science that can be taught at the freshman level. So yeah, how does data science apply to public health or linguistics or even philosophy has had one before. And faculty from all across campus teach these small seminars. The story is that they don't have to teach linear regression because we taught it to them already in Data 8. They can just say how it applies. Yeah.
I was going to ask about the economic modeling course. Is that actually in the business program or that's actually in the data science?
That's a great question. There's a separate connector course in the business school, and they're like, they have gone all in, and it's required for the business major to take the business connector. So that's a sort of a separate one. I'm trying to insinuate myself into something similar in the econ department. So I'm like a bridge between data science and econ.
Like you're in the data science.
I'm hired as a data science lecturer,
Okay.
but I'm offering content that's like a bridge between data science and econ.
Thank you.
Yep.
Uh-huh.
Do they have labs? Or on Data 8 is like 3 units lecture plus 1 unit lab, what the others?
Yeah, good question. So what about the kind of time commitments and labs for these courses? This is a 4-unit course, the data 8, which means they spend 2 hours a week in lab. All of these courses actually are smaller time commitments. These are 3 units. So, they're meeting 3 hours a week instead of 5. A lot of these are only 2 units. I think the numerical linear algebra course will be a 4-unit course with a discussion section, much like most math courses. So it depends, but yeah, we do try to set up our courses not to totally consume all of students' times, because semesters are really long. If you're on the quarter system, like semesters last forever. And so if you have a 4-unit course that's a semester long, then that really does take a block of their schedule. So I don't know if that answers your question. Actually, this has sort of been a moving target. Some of these courses, we started out as very small, kind of 2-unit seminars, and then we realized, oh, there's too much content. We need to expand them to 3 units. We didn't always have these. We had a program that was functioning reasonably well, even before we had, for example, a computational structures and data science course or a numerical linear algebra for data science course. There was just already a linear algebra course. Wasn't quite right, but close enough. There's already a programming course on campus. Was more tailored toward computer science, but it was close enough. And so that's how we kind of got started. But it has made sense to add courses over time in order to kind of improve the tailoring of content toward the students that we're getting.
I was curious, like, say the computational structures in data science, is that similarly to data 8? There's a lot of that on GitHub, is my answer.
It is actually. Yeah, people haven't asked for it so much, but it's a pretty interesting course. So we should make sure that it's available in case you want to work through it. Okay, great.
The new or linear algebra courses that require linear calculus still, or?
It is the case that linear algebra on this campus requires students to have taken calc for a year. And so, yeah, working through the major at Berkeley does require calculus for that reason. We have a core of upper division courses that a lot of our students take. These are all big. There's a human context and ethics of data course, where some of the themes I talked about yesterday are explored in much more detail, and students have to reflect on them. They learn a framework about how to think about ethics of data, and then they apply that. So there's like a really nice structured curriculum there. And then you have to go through lots of different issues and write papers about them. There's an upper division probability course. It's a lot like the upper division probability course that we had already in terms of its topics. But what's new is that we rely on the programming skills, and especially the simulation of random sampling skills that students built in data 8 in order to visualize and experiment with a lot of the distributions that you learn about. So you still have to write proofs, but you get to build intuition about the proofs before you write them. And then Data 100 integrates a lot of what they learn in the lower division. So it leans on their knowledge of programming. It leans on their learning SQL and also everything they learned in Data 8 in order to move into multidimensional data sets, data cleaning issues, things like that. And we have a whole 45-minute session on that. So I won't tell you too much, but I'm excited about that course. I've taught it myself and I enjoyed it very much. But again, it's challenging to teach in a way that Data 8 is, because it does include real world examples. Okay. And then, once you have a base like this, faculty just go nuts. This is my experience. So we have a variety of upper division electives that have been created, often because 1 or 2 people got together and decided this course should exist, as opposed to with careful long-term planning. But quite exciting courses. So we have, of course, Data 102, which it's kind of a wild idea. There were ideas that were taught in graduate courses that folks here thought should be accessible to undergraduates. About multiple hypothesis testing, about reinforcement learning, and basically how to make decisions with data using modern techniques. And even though these were traditionally not taught in the undergraduate curriculum, we thought, well, with this foundation, maybe you could get it. And so now there's a course that goes through a variety of, I would call them sort of machine learning topics, but they're a little bit broader than that because a lot of it is about decision making as opposed to just prediction. And that's now offered every semester and has 250 people in it every time. So it turns out that there are topics out there that just aren't in a typical undergraduate curriculum that could be and are quite relevant to data science. And I think we're seeing that kind of in a senior year course. Yeah, let's say introduction to machine learning here. It's a computer science course. If you've, it's sort of typical in the sense that it covers various ways of, supervised learning and unsupervised learning techniques and how they work. I listed it here because it's so popular among data science majors that we actually had our own offering of it just for data science majors with an instructor that wanted to teach just that cohort and let the other cohort of students, which is computer science and many others, take another offering of the course. So in that sense, it's kind of tangential to our program in an important way. Yeah, good question. So the question is there anything on the kind of pitfalls and biases of data science? I think that quite a bit of that is in the human context and ethics course. It was a graduate course that was very popular here about bias in machine learning from a very technical perspective, taught by Moritz Hart. And some of that content actually ended up filtering into this course, the data inference and decisions. So there's a unit there on kind of bias and what it means and what to do about it. Yes, that is in the course.
There's also Fernando Perez's talk on Stat 159 that we'll have it this afternoon is super related to this. And what I was going to mention is a phenomenon of the professor saying, can I get listed as data as well?
Oh yeah, that course definitely should be on this slide, and I totally left it. There's a risk that when you put all the courses, you'll leave out 5 of them. So yeah, I think the robust and repeatable statistics course that Fernando teaches should certainly be part of the data science collective.
So I had a question about like the courses that are listed elsewhere, data science related. If there's any sort of kind of issues with like programming languages, or like maybe some classes might use different programming languages, and if there were any students had any difficulties with trying to take courses that they wanted to take, but they might not know the programming language used.
It's a good question. Certainly that issue happens. I think it's probably more prevalent in the computer science course curriculum than here. Here, I think everything is either in R or in Python. And they start learning Python here, and they get it pretty well by the time they go through this course. The statistical methods for data science course teaches them R. And so there's like a very typical way to learn it. And then they're okay. Yeah, maybe I got that wrong.
To add, we also have a 1-unit art, 2 1-unit art courses that are meant to be introductions to art. One is for people who already know how to program, and the other is for newbies, and that's trying to bridge that gap.
But since a lot of the campuses converge to 2 languages, I guess it's not so bad.
Yeah, of course. Maybe I missed it, but are these courses all required? Which ones are optional?
Yeah, I haven't really talked much about the major and the minor yet, but I'll give you a sketch. You got to take this. You got to take this or some alternative where you learn how to program. Most students take all of these. There are some alternate pathways, but I think most students just take all three of these. And then they have some electives. And those electives don't have to be among this set. They can be, any technical course, and then there's a domain emphasis component. I'll talk to you a little bit more about it in a minute. But basically, no, these are not all required. But there's so much demand for the major and the minor that we do need to create dedicated courses, even in the elective category, just to make sure there are enough seats for students to graduate on.
One more question. Do not require data structures anymore?
We do for the major require the data structures course, which is a computer science course. It hasn't been tailored to data science in any way. It's just the standard data structures. For the minor, is not required.
So I wanted to ask about, for the instructors, say if maybe you're looking, do they in theory get to teach in whatever language they want, or do you like far?
Oh, good question. So what programming languages the instructors use when they teach these courses? These courses are quite stable, and the goal is to make them even more stable, because the way you get to scale is that you have students who have taken the course help teach the course, but if the course is changing all the time, then they're not as well prepared to do that. So it's definitely been a kind of design goal here that instructors don't get to decide exactly what topics they're going to cover or what programming language they're going to use, but instead teach the course as it was taught the previous semester, even if that's not exactly how they would do it. Of course, they have instructional freedom to tweak it however they want, but there's pretty strong pressure to keep things consistent so that the staff know what they're doing and so that the students get a consistent experience. And most people are on board with that idea here.
Thank you.
Yeah, it's something I would recommend if you have scaling problems. A lot of scaling problems just disappear if you repeat the same course over and over instead of changing it wildly every time. We've tried both, trust me. So anyway, so some of these will be touched on today, but I wanted to give you a sense of what's out there in case any one of these looks interesting. I'm happy to connect you with the instructors and you can learn more. And then, of course, because it's a major, we need other stuff like an honors seminar. Eric teaches that, career accelerator, teaching internships to get students involved in student teaching, that kind of thing. Okay, you asked about what our major looks like. I think I can go through this pretty quickly. We do ask students to take Data 8 and then take 2 semesters of programming, a programming and a data structures course, 2 semesters of calculus, and 1 or 2 semesters of linear algebra. You can do it all in 1 semester if you take the right course, but some students take 2. That's their lower division. Now they've declared the major. Take Data 100, which is the Principles and Techniques course. Take Human Context and Ethics. Take a course that extends the prediction and decision-making work in Data 100 to do machine learning or reinforcement learning or decision-making. So something that's quite advanced in terms of the technical aspect. Then these are really quite open. So the computational and inferential depth electives could be from departments across campus. And actually there are departments that are quite pleased to have so many students taking their courses that might not otherwise do so. There's always growing pains, but there are units out there that would be happy to have a few more enrollments. And that definitely happens through computational and inferential depth. And then we do require a 3-course domain emphasis. Okay, go ahead.
Is there a particular reason that the ethics upper division instead of lower division?
Why is the ethics course an upper division instead of a lower division course? There is a session on the human context and ethics program. So maybe you should ask that again. My sense is that we want the students to build up enough of the technical understanding that they can cover in this course some of the technical issues as well as some of the less technical issues kind of together, which it seems like a good structure. So it sort of falls in their time at Berkeley at the right place to be an upper division course. It's also very writing intensive. So yeah, so it's a fair amount of work. There is a lower division course, which I totally left off because we're not offering it this fall, but There is another course that's a lower division human context and ethics course that we've offered a few times called Data 4. And that's a course that really is accessible to first-year students and allows them to start thinking about the human context and ethics issues early. So I think that would be an ideal scenario for somebody who really wants to dive into that, is to kind of see the ethical issues both in the technical courses, but also in a dedicated freshman level course and a dedicated junior level course. And that actually exists at Berkeley. It's just not all students are following that path right now. And apologies out there to folks who teach that class. And it's one of many that I probably left off. Building domain emphases was an exciting task. This involved, a document, an agreement between data science and lots of different departments on campus, saying that we're going to add domain emphasis within the data science major in some area, and that these are the courses that are going to fulfill that. And the departments didn't have to dedicate seats, but they did have to agree that this was an okay part of the data science major, so that there was just an understanding that we were not forcing students on anybody who didn't want it. These turned into wonderfully productive conversations where people got to learn about what data science was and why it was relevant to the campus mission. And lots of people said yes. Some of these are more popular than others. And some of them are actually quite impacted. So students who are majoring in data science can't always get the classes they want in order to fulfill a domain emphasis of their choice. But they're pretty savvy around here about deciding where they want to focus. And they all seem to find their way. So it's not a big point of tension, but it is something that's tricky to execute. And you'll notice that this list of domain emphases conspicuously is all in the range of A to H. And that's because there's a whole second page of them. If you think of data science as combining inference, computation, and domain knowledge in order to learn something about the world, this really is an important part. And it also gives students a lot of flexibility, which means that we can draw students from across campus. I think the major is very academically diverse. Students with lots of interests, when they came into campus, have decided to study data science instead. But I think that only works because if they had a really strong interest in social policy and law, they can find a way to build their data science program to support that. Yeah.
Trouble getting into any of these courses.
Yeah, so each one of these little icons represents 3 courses that they have to take out of a list of typically 10. And Berkeley's a crowded place. So it's certainly the case that students don't always get the courses that they want, or they don't always get it when they want them. Yeah, we have an enrollment priority system, which basically means the longer you've been here, the easier it is to get into courses. And it's sort of up to them to figure out what they can get into. We don't think of domain emphases as an active constraint on the size of the program right now, because students seem to be finding their way into ones that they're excited about, even if it wasn't their first choice. They figure out how to fulfill the requirements of the domain emphasis, even if it wasn't with the classes that they originally intended. So we have other constraints that are a little bit trickier to solve. But there's basically like a long list, of course. And sometimes they're not all in the same department. Like the robotics domain emphasis spans mechanical engineering and computer science and electrical engineering. So yeah. And this is not a fixed list. Like we're working on an aerospace one right now because there's a new aerospace program on campus and we're trying to figure out how to connect data science to that.
Do they take the data 8 first they come here, or they have their own version of it?
All of these are just like 3 courses on top of the whole major where they take data 8, just that course. and data 100. And then these, oftentimes these domain emphases are not just data courses. Sometimes they're just the fundamentals you need to know about economics in order to think about data and economics together. But there's often a course within the area that really does integrate data science and the domain, but those are mostly relying on what they learn in data 8. Uh-huh. Many, but not all. Yeah. So oftentimes one of the 3 courses is a connector course, which is like a freshman level course, and then you take 2 upper division courses later, but not all of them. Uh-huh.
The point that is not on the, but yes, it would be.
We're working on it. Give me a second. Where's Anthony?
The data science minor, I was worried I would run out of time, and I kind of did. So I kept it short. The way we thought about the data science minor is that it should be something that pairs with lots of different majors on this campus, because data science is relevant to so many different disciplines. What we came up with as a sketch, and I'm happy to go into the details if you ask, is that they should take a lot of the lower division and the upper division human context and ethics course. So they have to take data 8, they have to learn some programming, they have to learn some probability, they have to learn some human context and ethics. That's kind of the core of the major as well. Then the major has, machine learning and technical electives and all of this. It also has data 100. Taking data 100 and its prerequisites, which are calculus and linear algebra, is one way to fill out your minor. But we wanted to make sure there was a path through the minor that didn't have as much of a math requirement, because for students to complete a full major that does not require calculus and take calculus and linear algebra is just a lot to fit into 4 years. So there is a second pathway. Sorry, I should have listed out the names of these courses, but this is the statistical methods for data course, which I mentioned earlier, and a course about programming in the context of statistics. So yeah, I think if you think about a minor as pairing with whatever major students are doing on campus, then it does require a fair amount of flexibility.
Are you saying those subdivisions that course do not require calculus?
Is that right? I think they do, but you can take it later. They don't require linear algebra, right?
By definition, the idea was that it did not require linear algebra.
Yeah, 133, I definitely is listed as no prerequisites, but I think a lot of the students in it have taken calculus anyway. But the goal is to have some path for you to. Uh-huh.
If you have to guess, what would be the what would be the ratio for minor major?
Oh, good question. So how many people are majoring versus minoring? The major is actually where most of the students are these days. We have 700 students a year graduating in data science, something like that.
Minor is newer.
The minor is much newer, and it's already big. I wish I knew the numbers. Laura still here? No.
Aaron,
Oh, okay.
1,000 majors or something like that. Yeah.
Yeah, so probably 600 or 700 people are planning to major to minor, but that doesn't mean per year. That's like across the campus.
Ballpark.
So 300 a year or something.
Does Jupyter Labs fit into the staff courses? Are they using, is that being used in those kind of courses?
You like a notebook format for
Yeah.
programming?
Yeah.
I'm not as familiar with those courses. I'm guessing they use RStudio. Maybe Deb knows.
Right.
Uh-huh.
I used it.
Yeah, someone mentioned there's our notion of Jupyter notebooks. Jupyter supports R and many other programming languages. Actually, our auto grading infrastructure also supports R and many other programming languages. We do want to set up the the tools that we build in order to be flexible. But then you have to think about what's the student experience. And so here, because we teach our intro courses in Python, we have a lot of other courses that also use that in order to make sure the students don't have to shift around quite as much, except for they do often learn R as well, because it's a common programming language.
Is the linear algebra the same as the regular linear algebra, but or it's different, like in programming is it?
Yeah, good question. So is this linear algebra the same as regular linear algebra? Is it somehow different? The way we just structure our degree programs is to give students options, because that helps them fulfill their degree when a course might be too small. So we have a linear algebra requirement for the major, which can be filled by any linear algebra course on campus, including the one that is specific to data science, which is brand new, but also the one that's been here forever and was kind of designed around supporting engineering, and a specialized one that combines electrical engineering and linear algebra. It's a 2-course sequence in particular. So the story is basically, however students want to learn the content, they can, if there are multiple paths at the university. And the same story is true with programming and probability and human context and ethics and machine learning. You know, basically, except for data 8 and data 100, there's quite a bit of flexibility in how you fulfill your degree, but we offer a typical option that's tailored to data science. And that's allowed us to scale up a little bit more quickly than if we said you have to take this particular course for every requirement.
The data structure has to be Python or just Java?
The data structures course is in Java. Oh, great questions. I left myself 1 minute to talk about co-curricular programs, which is woefully inadequate because these are essential to the enterprise. But I mentioned briefly, well, you heard about data scholars. That's something that you start in your first course, but is a community building and resource offering program for your whole time as an undergraduate. We're building a career accelerator program to give career coaching and internship opportunities. We have a wonderful research discovery program where students work with external groups on their data science problems. And you might wonder, if you have a bunch of undergrads working with an external group, does anyone know data science well enough to make progress? And the answer there is that we hire graduate student mentors to help guide them, so that if the institution that needs help and the undergraduates aren't quite sure how to solve a problem, at least there's a graduate student there to help them along. So anyway, there's an array of co-curricular programs that we're building. Since everything's kind of brand new, I would say that they're not as rich as some of the other more established programs on campus. We have a fair amount to build still, but I'm excited about each part of them, and the students seem so as well. So yeah, that's part of the fun next 5 years, is figuring out what these co-curricular programs look like. Okay. I'm gonna get out of here and turn it back over to Eric.
Well, let's turn it over. Can you?
Oh, okay. Next up, Associate Provost Jennifer Chayes, who's organizing that, what I briefly mentioned, Computing Data Science and Society, which is one of the most exciting initiatives I have ever seen on this campus. And now you get to learn about it from her and ask her lots of questions. Thanks, Jennifer.
We have this funny thing where some people are too.
What is that?
That is an owl that's recording you, so
Oh,
you'll see your
okay.
face here.
Okay,
So the people who
great.
are streaming will
Great.
see you. And then we're going through the slide deck using arrows, or you can. You got it.
I'll use an arrow or enter. Does that work? Let's try that. Enter.
Yeah.
But then I have to go back. Good. Okay, I'm a somewhat different height from John. You may notice I'm getting swallowed up behind this. Okay, but I'm loud and have a big presence, right? have a friend back there, a plant probably. Okay, so I'm going to talk about this new college that we are forming. We are still a division, but we're very much on our way to becoming a college. This is, from an academic perspective, probably the biggest transition or transformation that we've had at Berkeley in half a century or so. And it's really in response to the way the world is changing. Which is, of course, a big part of that response is the data science program. And this never would have happened without the data science program, but we're both responding to the same thing, which is that computing and data science have become the fabric of society. These are the platforms on which we innovate, communicate, transact, make decisions, and allocate resources. And we're doing that now to some extent. It's going to be ramping up so much over the next decade or so. So, we can't simply have computer scientists making these platforms and then we use them in all these applications. First of all, we really need statistics because you can't draw proper inference without statistics. Okay, so much of what people talk about when they talk about machine learning is actually statistics. I mean, they'll tell you about certain things. It's actually the domain of statistics. So I think that statistics and machine learning are both central to these platforms. But as we do this, there are some wonderful things. So let's just think about the last few years. Okay, as most of us are white collar workers. So we were very lucky, relatively speaking, during the pandemic. We could conduct our lives over these platforms that we had established. We could, get someone to shop for us. We could use telemedicine in many cases. We could visit with friends and family whom we couldn't actually visit in person. So much of our lives were taking place over these platforms. However, at the same time, there are tremendous downsides of these platforms. There's bias in these platforms, and as we saw on January 6, 2020, when power is created on these platforms, that power can get usurped. So, I'm preaching to the choir here, but we can't have the computing, the platforms, the statistics without deep involvement with all other domains. And that is really what data science does. Okay, it means that these are not separate enterprises that get put together later. If we had had more people thinking about the long-term effects of certain business models for social media, we might have arrived at a very different point than we're at now. If we, now we're more and more making decisions on these platforms. For example, we're making bail decisions. We are making decisions on who gets certain resources in the public health arena, or which schools kids get into. or how we allocate resources, social service resources. And, we need to be cognizant of, as we do this, the unintentional biases that come in here. We also need to be cognizant of the fact that as these become more powerful, people are going to attempt to usurp the power of these platforms. So in the same way that today, I can change a few pixels on a stop sign and a self-driving car will not stop, even though to a human being, the stop sign looks the same. Just imagine that in the future, as we're making decisions on allocation of public health resources, someone could go in and change some records in a way that doesn't seem like a red flag to a human being looking at it, but you can really change the outcome for a group of people. It could become not unintentionally biased, but intentionally biased in certain ways. And so, it is our responsibility to educate everyone in college, and hopefully even as time goes on in high school, to be citizens of a civil society. You are going to have to question the sources of data, the incentives implicit in what we're doing. So, this is a form of literacy, data literacy, algorithm literacy, which doesn't mean that you're a data scientist, but it does mean that that you're not going to be able to make the right decisions or evaluate things or build the things you're going to build, whatever area you are in, without these considerations. And so, what this has done is it's really changed the landscape for universities. And as we're building this College of Computing, Data Science, and Society, we are thinking of it as a place to educate, which is what we're talking about now, to do research, to innovate, and also for impact. I think that a lot of universities thought of themselves as having, well, all of them, all colleges and universities focus on education. Many of them focus on research, but I think we all also have to think about impact now. I think that becomes for universities to remain relevant. We can't just say, oh, someone's going to take whatever we do and they're going to take it out into the world for us. I think it's our responsibility to really take it out into the world. So these are the considerations that are motivating the formation of this new college. So as I said, we're on track to become the first new college at Berkeley in over 50 years. In the 1960s, we formed a School of Journalism and a School of Public Policy at Berkeley in response to what was going on in the 1960s and how the world was transforming. And I think this is at least as powerful a transformation. So what's going to be in our new college? By the way, the decision is now sitting with the office of the president of the UC system. It's gone through multiple steps over the last 2.5 years to get to this point. So we're almost there. We are sharing the Department of Electrical Engineering and Computer Sciences with the College of Engineering. From an institutional point of view, that's a pretty complicated thing to do. In fact, the faculty there decided that rather than one dean handling, the hiring and promotions for one group and the other hiring, doing the hiring and promotions for the other group, the faculty decided they wanted double jeopardy. Since we agree on essentially everything, we've never had a disagreement in 2.5 years. I don't think it's a big problem, but this is really an integration of engineering and computing, data science, and society. The Department of Statistics, and these were the original data scientists, of course, were the statisticians. They are in it. The School of Information, which has actually a very popular online master's in information and data science, is part of us. Of course, there's data science undergraduate studies, which is what we're focusing on here. We also have a Center for Computational Biology that has about 40 or 50 affiliated faculty from around the university, including some who have positive fractions of their positions there. We have a new, very exciting program jointly with UCSF, where we have joint faculty and a joint graduate program, and the students will receive degrees from both institutions. I'll talk a little bit more about that and how some of that, it's just being formed now, how some of that will probably come down to the undergraduate major level, maybe be a designated emphasis or something like that. And then the Berkeley Institute for Data Science. Okay, so we have a fourfold vision. The first, which is what we've been discussing here, is to educate diverse students to approach data ethically and masterfully. And I think both of those are really, really important. If we just educated people, to be whizzes at, at computing and statistics, we might be creating more harm than good. So I think that's really important. Also, diverse students. My mom could not add fractions, and I won the highest award in the world in applied math, given out once every 4 years. I kept teaching her, trying to teach her how to do percentages. But she couldn't understand, just shifting the decimals or something like that. So I don't think, and her mom got married at 11. Maybe she had her first miscarriage at 11 after she was married at 9, something like that. So, it's just, you need to have all voices at the table, you really do. And what your background is, what your parents' aspirations were, should not determine what you do. And I think one of the critical things for us, our data science program is now over 50% women, which is amazing and wonderful. But we still are not doing nearly as well with minoritized students. And so this is something that we all have to think about. We all have to think about why. These are the students we really need at the table, because the technologies that we build are not going to be the right technology. So how do we really create more entry points? I mean, we see it with minoritized students, but they're probably also, it's much more correlated, I think, with whether you're first generation, what the economic level of your family was. So I think this is really, really important. And that's something that I know that we in our data science program are really working on, trying to find ways to make sure that our population in data science reflects the population, certainly at the university and hopefully throughout the state of California. We also want to advance the state of the art, of course, in core computing, data science, information, and statistics. We want to found new fields which bring computing and data science together with other disciplines. So on a research level, you know, we want the people who really work together, you know, on biology and computation, or climate science and computation from the beginning, or social justice and computation from the beginning. And we also want to make sustained progress on issues of human and societal significance. So, you know, sometimes we talk about STEM and non-STEM, and that always really bothers me, because why would you define something as not something else? I mean, I know we take compliments of sets and everything, but we shouldn't do that in fields of study. And so, you know, I like to think of STEM and the human-centered disciplines. And then we really need to sit at the intersection of these. Okay, we really need to be a fundamental part of that intersection of STEM and the human-centered disciplines in order to make sustained progress on issues of human and societal significance. Okay, so education at scale, you've probably already heard this, a number one data science undergraduate program. You know, I think there was finally some rating by somebody who came out number one. You know, really, this is, you know, what I'm most proud of is that we just have an excellent data science undergrad program. Number one, computer science undergraduate program. Number two, computer science and statistics PhD programs. And in the School of Information, we have a number two rated master's in data science and information in data science. So we are educating at scale, but really it is this activity here that means that we're educating at scale. It's not 700 to 800 graduates a year in data science. It is our shared platforms, our shared curriculum with all of you that means that we are educating. We are all together educating at scale. Because if we just did this at Berkeley, you know, I mean, that's not going to have an impact on society. But collectively, we educate at scale and we have an impact on society. Oh yeah, this is something new. We're incredibly excited about this. There's a Berkeley Tuskegee data science initiative, which was just launched. And so I think we have some of the folks from Tuskegee here. Yay. Okay. And really, folks from Tuskegee approached us almost 2 years ago, and I am so happy that they did, because Tuskegee really implements effective practices that expand opportunities for minoritized students in STEM, and explores research and curricula that combine social science data and intersectional identity. And so the Tuskegee partnership brings so much to Berkeley. You know, some of the things that which we do not do that well. And hopefully it will bring something to Tuskegee. And hopefully we can, you know, we're even thinking of doing joint degrees at some point, maybe a 4+1, or, you know, but we're really, really, really excited about it, because we have so much to learn at Berkeley, and this partnership is really going to help us to learn, and it's going to help us to create the kinds of leaders that we all need. So yeah, we're gonna have faculty and student collaborations. We've got, I think, 13 Tuskegee students have just started in a summer program here, and that's the beginning of it. So we're really excited about that. Okay, and then research. So you know, I think of what we do as foundations. So there's core computing, data science, statistics. There's applications, which are the myriad applications that you saw referred to in the disciplinary emphases and more. And then there are implications. And the implications, as I started out talking about, are really, really important. And if we do applications without thinking through implications, we all have to think, I think a little bit like a cryptographer, and kind of kick things and say, how is this powerful stuff that we are developing? How could it go off the rails? How could it be hijacked in some way? You know, I think the political situation in which we are all living right now tells us that we have to think through implications of all of our actions and all that we create. And so that has to be a fundamental part of our research. So we have three big emphases from a research perspective in our new college. By the way, it's really going to be a big college between the data science major and the computer science major and the statistics major. You know, we're going to be probably by undergraduate, the number of students graduating with an undergrad degree, we're probably going to be the second biggest college after letters and sciences, which is of course huge here. It is the core of Berkeley. So what are the things we're focusing on from a research perspective? We're thinking a lot about biomedicine and health, climate and sustainability, and human welfare and social justice. And I'll talk about each of these just for a couple of minutes. So biomedicine and human health. When I came here, I thought the one problem with Berkeley was that we didn't have a medical school. But of course, we have a medical school very nearby at UCSF. You know, we want to get, in order to have impact, we want to get what we build out into the real world. And so we built this program that's going to start out with a PhD. We just, you know, we got a $50 million gift from an anonymous donor to start the program that came through in September. And the result of some talks that took place just last June. And we have hired our first 3 faculty members. They're absolutely fantastic. And we will start a PhD program in about a year. And so what is that PhD program going to have? Well, it's going to look in many ways like a graduate version of some of the of data science. Okay, we're going to have AI and machine learning. We're going to have data structures. We're going to have high dimensional sparse statistics and causal inference. We're also going to have physiology, anatomy, clinical decision making, and every student is going to be in the clinic working in teams with patients. So it's understanding the human dimension of the problem and how do we take this myriad of data that is before a health practitioner and before a patient and give the best advice possible to the health practitioner. Also, it was really important to us to have ethics, as a huge part of this. And at first, we were gonna design 1 or 2 ethics classes. And then we said, no, there needs to be ethics in every single course we teach. There needs to be ethics in anatomy. How can, as they learn about anatomy, how have the ways in which we have decided on norms affect the quality of the treatment? I don't know whether you know this, but all the big machines, or even little things like my Fitbit, are not, but also like the MRI machines and the CT machines, cannot be properly calibrated for someone my size. They're just not designed for, someone who's 5'2" little. They're probably not calibrated properly for people of different races. So, how do we, as we think about everything that goes on with healthcare, how do we think through all of this? And how do we come up with studies which demonstrate this and ways of innovating so that this will no longer be true? Also, we have very much a public health focus. The director from the Berkeley side of this is a woman who's in public health, Maya Peterson. Our big work before this, she had a $21 million grant for AIDS in East Africa. So she's been working on AIDS in East Africa. And the mayor of San Francisco last year, spontaneously to her surprise, called a Maya Peterson Day for all the work that she had done for the unhoused with COVID. So, this is going to infuse what we do. And over time, of course, we want to bring this down to disciplinary emphases within our data science program. Climate and sustainability. This one is just such a hard one, because there are, of course, there's, modeling of the earth and the atmosphere. There's environment and ecology, there's material science, there's human behavior, there's economic incentives. Really, really hard problem. And then there's, the difficulty that our individual actions don't have that big an effect. And so how do we, collectively they do, but, I could drive a Hummer and everybody on my block drives an electric vehicle, and, I benefit from all of them and they suffer from me. And I don't drive a Hummer, but, so these are really complex problems. We're trying to deal with pieces of them. We got a $12.5 million grant from Eric and Wendy Schmidt for data science for the environment. That's the name of the new center. And that's really using data science to study ecology and the environment, both on land and in the oceans. So that's very, very exciting. I have recently started talking with Omar Yagi, who is an amazing chemist here. He's won all the highest prizes except the Nobel Prize, but he may be getting that one of these years. He grew up a refugee in the Middle East, very, very modest means. He developed a new class of materials that pulls carbon dioxide out of the air. There are these metallo or organic frameworks, which are like these aerogels that kind of, they pull carbon dioxide out of the air, and then you can kind of unzip them and the carbon dioxide goes away and you reuse them. So that's for carbon capture. he's more recently, maybe the past 4 years or so, developed a class of materials that pulls water out of the air. And even if the air is dirty, it pulls clean water out of the air. And he was telling me, I can have a device at some point sitting on my kitchen counter that pulls out 200 liters a day of clean water, which could be absolutely transformational to so many people in this world. So we're talking about wanting to form an institute for digital materials for the planet. So these are different aspects of it. Very complex problem. And then human welfare and social justice. So we're doing a lot of research in this area. This picture of Rediat Abebe, whose whole research agenda is devoted to that. I also want to mention another project that a few other people did recently. The Innocence Project, which gets people off death row, came to the Berkeley Institute of Data Science a year and a half ago or so, and said because of police misconduct, demonstrated police misconduct, the NYPD was being forced to release a lot of data, kind of as a punishment, okay, and to help people look for more police misconduct. And, obviously the NYPD wasn't going to make this that easily accessible. So there was, body cam, there was video, there was audio, there was things written on scraps of paper, there were spreadsheets, there were, just multimodal data, really, really hard to sort through. And they asked if we could help them look for exonerating evidence of police misconduct to get people off death row. And so a team led by 3 of our faculty in EECS and the School of Information not only did that with really sophisticated AI and ML data science on the back end, I mean, just absolute state of the art for, multimodal data like that, but also they built front ends that are low code, no code. And they have been meeting every week with the National Association of Criminal Defense Lawyers. And they're building a tool for defense lawyers who have no training in data science, using program synthesis and other things like that to kind of ask questions and then model, synthesize programs from the interaction that they have. So that, one of the big problems in criminal defense is that there's a body of evidence. The prosecutors are looking for evidence of guilt in that body. The defense attorneys are looking for evidence of innocence. And, but all the resources are on the side of the prosecutors. And so what this tool is doing immediately is really leveling the playing field, not only to get people off death row, but to keep people from getting on death row and to keep people from being wrongly convicted. So, these are the kinds of things that I believe our data science majors are going to be going on and doing in the world. We want to train them for this so that they become data-driven leaders with human perspective and purpose. Okay. Questions?
Thank you so much for sharing that information, and I commend the vision of you and your faculty about this new college, and I wish you much success. The Berkeley Institute for Data Science, describe its role in terms of when it was created,
Mhm.
and now it's rolled with the potential of the new college.
So it was created as a, that Moore and Sloan, the Moore Foundation and the Sloan Foundation got together. Guess it was probably 10 years ago, I don't know what, 2014, so 8 years ago. And they they put up, $30 million for 3 institutes, each for 5 years. So it was like 2 million a year. And there was a national competition, and they chose Berkeley and NYU and the University of Washington. And so each university did it a little differently. Here we formed the Berkeley Institute for Data Science. We no longer have more Sloan funding, so it's it's a little more of a heavy lift. We catch where cats can. I mean, I'd like one of my goals is to get more steady funding for them. But we have all kinds of research projects from all over the university. So it is a convener for what it first started off, things more in the like scientific realm, like astronomy and physics and biology, earth science. By the way, they brought in Fernando Perez, who is the inventor of Jupyter. He now is a faculty member in statistics, and he is the one. I mean, I like to think of our new college as the platform college, because if you want impact, you need scale. And you get scale by building platforms, but you do it in an open, collaborative way so that everybody can benefit from it. So anyway, that was a huge part of that Berkeley Institute. There was a lot of the creation and growth of Jupyter started, and so that was one of the things that BIDS, as we call it, Berkeley Institute for Data Science, was really known for. Over the years, it's now become also much more socially focused, like this, people coming in and asking questions about the Innocence Project, or looking at questions involving voting. And much so now it's really doing both. And I see it as a really fundamental piece of the new college. In fact, we're building a new building for which we have to raise $577 million, all philanthropically funded. We've raised 322 so far. This is how a public university does it. And a really central space there is going to be occupied by this institute, a space that brings together people from across the university to launch these collaborations, and bringing in also people from outside to start forming, the collaborations. But because we try to build platforms, those collaborations are also coming about in a sustained way. So I think it's really incredibly helpful to have a place that really becomes fertile ground for the genesis of these new fields and these collaborations. And I know in fact, I reached out to one of the people who's now one of the leads on this platform for criminal defense attorneys. And I said to him, now you have a chance to bring, I knew his political passions. And, I think it's really wonderful for people from technical fields to be able to all of a sudden unite their, the things they care about as human beings with their more technical expertise, right? To bring those together, it's a revelation. It's really wonderful. So, so anyway, I hope many more things start there, and that's going to be kind of a little bit of an incubator, not of businesses, but of new research projects for us. Yeah.
I have what might be a silly question, but so I assume the migration from a division to college gives you financial benefits, you get a stable, all that. I mean, but what's the is division is like a unique thing.
Well, yeah, I mean, technically at the University of California, a division, which is not under a college, cannot hold faculty and cannot grant degrees. So
That's a non-trivial.
that's a non-trivial difference. So we have been given an indulgence, I mean, it sounds biblical, an indulgence from the office of the president. That wasn't realized at first when I came here. The job I came here for didn't exist. We were given an indulgence to start moving in faculty as we're on our way to a college. We cannot move in the majors. I mean, we cannot grant the degree in data science or in computer science until we become a college. And so there have been all kinds of complexities in that. I mean, I'm doing a great deal of fundraising for, you know, to be able to hire teaching professors, to be able to help with our model of using teaching assistants as instructors, which is quite expensive for us now that we pay tuition for the students as well. And so, you know, just aligning those things. And I think also creating a home. I mean, I think that's really important for our students, right? That we're going to create a place for them. So in this new building, we have, you know, beautiful places for our students and for our advisors of the students, but also, you know, kind of more of a, yes, we get assistant deans then for DIBJ and for other things. So it will be somewhat more resources, but you know, the university has a fixed cost. And so that's one of the reasons that I've been spending so much of my time fundraising, because I want this to be something which raises all boats, which doesn't take away from a fixed pie. But yeah, I mean, creating a college that is a home for these students, I think is really, really important. Now, I still hope that in data science, many of the students will enter through letters and sciences, because many of the people I get most excited about are the discoverers, people who wanted to do something else with their lives and found out that doing data science is a way to be a data-driven leader in whatever they wanted to do. So even when we become a college, we're going to be a different kind of college because of the deep interdisciplinary nature, both for our students and for our faculty. You know, and I think that's what's required, and different colleges or different universities are doing different things now. Some have formed institutes which actually do hold faculty, but not students. Our institutes are not allowed to hold faculty, so I think that's really important. Anyway, so yeah, so it was a huge technical difference, but I think the biggest part of this now is creating a real home for these students, and this place that brings together students from across the university. Yeah.
Another question, kind of relating to that. Berkeley here would have a huge number of applications, freshman applications to computer science, them rejected. So then how do students, the applicants, know that they can apply to data science? If you don't have a major in data science, but then you want to draw a student from literary sciences and computer science. So how would you disseminate that kind of information?
So yeah, I worry about this all the time. And, computer science is too overburdened, that major, the major has been capped and it's been capped in very difficult ways with a grade point cap, which I hate because, who gets through that grade point cap, often correlates with the quality of the high school, which correlates with the economic background of the students. So it's awful. We are really trying, and John is our hero here. We are trying to keep data science completely open. Okay, we just got some more philanthropy to help us with this. Students learn about this. They come in here, they want to be, a social science major, and then they become maybe a double major in sociology and data science or something. Once we become a college, I think that students will be able to apply directly to data science and get in, and hopefully they'll learn that that's an easier path. They have an easier time being accepted than computer science, which is too overburdened. But also when they come into letters and sciences, I mean, we need to do a lot more outreach. And I also want to start doing more outreach to the high schools, because I think that that's just important to create the pipeline. Yeah.
I'm at a local community college and also volunteer teaching at the high. So what to just say is that try to apply to some major history, and you come to carefully backdoor into data science. See that?
Well, you don't need a back door to data science. I mean, you can say right now, you can list, you'll be able to list on your application that data science is your first choice of a major. Okay, because it's a major that exists right now in letters and sciences. It's going to move into our college, but people are still going to be able to say they want to do a data science major from college. And mentioning community colleges, we get phenomenal transfers. And we are working, Deb Nolan especially has been working with community colleges to make sure that the curriculum is similar enough that the students are in good shape when they get here as transfers. Yeah. And then I'm over time. I just want
I have students find I got 4.0, get rejected in computer science because I did not know I should also list data science, because there's nowhere at the college we got information on data science now is also amazing.
I would like you to please write to me and John, okay? And I want to take that to people, because I have been saying this and they're like, oh, students know. So I would like evidence that students do not know, because that's been my worry. And so the more evidence we have, the better.
And I think that's why we're all here. Like,
Yes.
that's what we're doing here. That's like why we've gathered, is to make this happen and to bring this transformation and to spread it around. So that's a really great prompt for all of us.
Yeah.
And it gives meaning to this workshop. Thank you so much. We're breaking for coffee in the other room, but we're going to come back pretty promptly at 10:45. We've got so much awesome stuff to get through. Yeah.
I'm all hesitant about it, because if I give you slides, then I'm gonna talk to you.
I know.
You know?
2 slides, 1 slide. I mean, you're gonna have like a slide that says your name and add and like add
Like,
the whole.
there's like
Because
the
you want-
URL. I want.
Yeah.
Right?
So why don't you make like,
Email it to you?
yeah, email it to me really fast. No, we're going to coffee now. That was interesting.